So we know how to take the derivative of simple polynomials and simple trig functions. What we don't know how to do is how to take the derivative of functions that are being multiplied together. Okay? Now, you could, so if you had, don't write this down, 2x plus 1 times 3x plus 2, or squared, okay? If I said take the derivative of this, you could expand out the brackets via foiling, collect all your like terms, and then do the derivative, because you'd have 4 terms separated by addition or subtraction signs, and you can do each one separately. What the product rule allows you to do is just do it the way it's written. Okay, and this will become more important when we couple it with what's called chain rule. When I start making, well, not me, but when these powers up here become 3, 4, 10, whatever, because you do not want to expand this, right? Because that's going to be a lot of work just to expand it. Whereas we need a rule that will allow us to deal with it the way it's written. And that the beginning of that is the product rule. So, like I said, you don't need to know the proof, but I think it's valuable to see where it comes from. So if we take the derivative of two functions being multiplied together and we apply the limit definition of a derivative, does anybody remember what that is? That's what a derivative is. It's the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Got it? It's this. Here, I'll show you. It's here, right? There. There it is right there. Boom. That thing. Remember that? Okay, so we're going to do the exact same thing except you have two functions now, f and g. So what it looks like is when you apply that is you get this. The limit as delta x goes to 0 of f of x plus delta x times g of x plus delta x minus f of x, g of x over delta x. All right. So I punched it into the limit definition.
Please excuse the interruption. Any grade 10s who have not done course completion, course registration, come to the Learning Commons and do your course registration. So any grade 10s. Thank you.
All right. So I get that. Okay? Now, this is the magic part. You can stare at this all day, nothing's going to happen. What somebody figured out is they said, what if I do this? First part stays the same. Excuse me. But then they said, I'm going to add in this. I'll explain it in a sec. Yeah, they add to 0. The yellow part is the same, right? One's positive, one's negative. So really you're just adding 0. Remember in grade 11 when you're completing the square? Do you remember that for parabolas? You would add a 0 in there, right? Plus 4 minus 4. It's the same idea, except now it just looks weird because it's all functions. Okay? All right. So then is everybody good with that step? Right? This is just adding in a 0. And I'm going to show you why they do it here in a sec. Okay? The yellow part just adds to 0. Then somebody said, well, if we do that, and then I look at, I sort of cleave it, and I look at this bit right here. What can I factor out of that? The f function, f of x delta x. You don't have to. I'm not going to ask you to reproduce this. So if you factor it out, you get this. And I'm going to split this into two parts. And then the second part, this bit, I can factor a g of x out. Is everybody okay? All right. What is that? It's not a number, people. It's no. What concept does it rep? It's the what? It's this. I'll scroll up. It's that. Right? So what did we generate? It is, so this bit, this part that I circled in yellow is G primed, right? Because it's the limit as delta x goes to 0 of that gunk. The other part, this f function, if I put delta x goes to 0, I'm left with, if I put delta x is 0 in here, I'm left with f of x. Plus, and then we look to the other side. What is this? F prime. So I'm left with g of x times f prime of x. This is the product rule.
We write that down, right?
Yes. You should write that down. That is the product rule. The derivative of two functions being multiplied together is the derivative of one of the functions, or the first function, times the other function, plus the derivative of the other function times the first function. So product rule takes a simple expression and it makes it a little bit bigger, but it's, in the long run, it's actually easier to deal with. We're going to do quotient rule today too, but we'll do product first. All right, are we okay?
I'm still doing that.
Oh, okay. All right, so do a couple of examples. Find h prime of x if h of x is equal to. That. Okay, so you could expand it, but like I said, as soon as we start to put exponents on those brackets, you don't want to expand it. Do you want to move it up? Is that better? Okay. So we're going to do it using product rule just because that's what we're practicing. Product rule says. Now it doesn't matter which one you do first in product rule because we're adding them together. You're going to see in quotient rule the order does matter. So I usually do f prime first, but it doesn't really matter. You decide which is f prime, which is f, and which is g. Doesn't matter. So f prime. So just look at this. What's the derivative of that? 3 plus 4x. That's it. So h prime is going to be 3 plus 4x. So this is this bit. This is f prime. This is f prime of x. And then you multiply it by the other function g of x, which is just 5 plus 4x. No, just the function. You don't do the derivative of it yet. And then this is g of x. So f prime g of x, that's this bit here, plus, and then you do g primed. What's the derivative of the second bit? Matthew? 4. So that's g prime times f of x, which is this stuff here. That. So that's f of x. So it takes functions that are simple, and you're going to start to find this with chain rule and things like that. It's going to take a simple function, and it starts to blow it up. Okay? Now we got to simplify it because this is ugly. So we're going to have to FOIL it anyway. Why is there a 4? That's g prime, the derivative of this.
It's just derivative times function.
Yeah.
Plus derivative times function.
Yeah, that's exactly what it is.
Yeah.
All right. Now we got to FOIL. What's 5 times 3? 5 times 4. 20x. 4x times 3 is 12x. 4x times x is 16x squared. And then this 4 gets dumped in, and you get 12x plus 8x squared. We're making it look nice now. Whoa, that's bad writing. Whatever. And then just clean it up. 32. What's 32 and 12? 46? 44. That I'm really good at math. And 24, right? Okay. Polynomials of degree 1 or binomials of degree 1, product rule is not that much faster. It really has applications, though, when you're dealing with trig functions. You don't want to? No, just leave it. Walk away. We're not going to factor that. Okay. It depends on what you're doing, right? If you had to do the second derivative, which we'll learn later on, you would want to leave it like that because then it's pretty easy to do that derivative. All right. Let's do a trig function. So now we're doing the derivative of x squared sine x. Okay. So this is product rule. Does everybody see 2 functions there? No? There's f of x. There's g of x. So the trig function these are like 2 functions being multiplied, right? X squared is one function and sine x is the other function. So then, sorry? Yeah, because they're not being added. So then we go, okay, we're going to use product rule because it's two functions being multiplied together. So so I'll just write it out. Come on. So I would say this is what we're going to do. You don't have to write this out every time, and then you just fill it in, basically. Right? What's f prime? What's the derivative of x squared? 2x. G is just sine of x. Plus, what's the derivative of sine? Cosine times x squared. So I'm just going to put the x squared up front. That's it. Remember what we did on Friday? The derivative of sine is cosine. The derivative of cosine is negative sine. Okay. We okay? All right. Here we go. That's the answer. I mean, depending on what you're going to do after that, you're going to want to factor or not. But for right now, we're just going to leave it like that. We're just practicing derivatives now. Okay. So there's two bits here now. So the first part, anytime there's an addition or subtraction sign, you can just deal with that separately, right? Later on. We're focused on products, i.e. what's being multiplied. So this is where product rule is going to be applied in this part here. So I can call f of x 2x, and that's g of x. Okay. So product rule occurs on this part. All right. F prime. What's f prime? 2. Times the other function, which is cos x, plus g prime. What's the derivative of cosine? Negative sine times f of x, which is 2x. I'll clean this up after. And then this bit, the second bit here, you can just do a normal derivative on that bit, right? So we just go minus, what's the derivative of sine x? So it becomes minus 2 cos x. Does that make sense? You only have to use product rule if they're being multiplied together. If they're being added or subtracted, you just deal with those separately. Okay, now we got to clean this up because this is gross. What happens to the blue? 2 cos x, and the front 2 cos x. They go away, right? No more cos x's. And so you're left with negative 2x sine x. Is that okay? All right, one last one. The derivative of cosine x times sine of x. You want to try it on your own? Freeze it. See if we get the same. We get it? That?
Not even close.
Did you get this?
Yeah.
Then you're fine.
No.
You got that, you're fine. It's actually a double angle identity if you remember math 12. Cos squared minus sine squared was cos 2x. No, if you got this, that's still right, but the tendency is not to have a leading negative. But yeah, that's still right. Okay, so you got that? Everybody got this? Okay, then you're fine. This is better. This is superior. All right, practice questions. 125, 1, 3, 5, 39, and 63, please. And then we'll do quotient rule.